In this video, I'm going to review the two ways we've learned to divide so far and explain what division means for those of you who are still confused. So I'm going to write a division problem. And let's first just talk about what each of these parts of the problem are called. The 384 would be your total amount of something. And the math term is dividend. Okay, so this is what you start with. You have this, and you want to break it up into 5 equal groups. And that's called the 5 is called your divisor. Okay, so that's your divisor. When you write your division problem this way, or you see it this way, the 5 is on the outside and the 384 is underneath. Now, in my class, we talked about a couple ways to remember which goes where and what each one means. And we said when you see the problem written this way, the dividend is in front. Okay, so we think of it as the first number. And it's like, just so that we would have something to think about mentally in our head, we said, okay, this one gets to be in the house because it's the big guy. And this 5, the divisor, is knocking outside of the house and seeing how many times it can come in. Okay, just ways in your mind to think about it. Because I know sometimes it's confusing to know which one goes where and what do they mean. So we talked about 2 different ways to divide, to find equal groups. And, because again, that's what you're doing, finding equal groups. One way we did was drawing pictures. So I'm going to start with that method. So if I wanted to draw a picture to represent this 384 total, and I'm breaking it into 5 groups, I think I'm going to do this. I talked about this with my class, and we kind of put it on the side and made 110s 1, but I know that a place value chart, I know that you learned this in 3rd grade. So when I think of 384, that means I have 3 hundredths. Okay, I'm going to put my 3 hundredths, 8 tens, 1, 2, 3, 4, 5, 6, 7, 8, okay, and 4 ones, 1, 2, 3, 4. Now what they're asking us to do in this problem is to break that into 5 equal groups. So what I'm going to do, and I have this nice big paper, and I suggest when you're doing problems that you use a nice big paper. 1, 2, 3, 4, 5. This is representing my 5 groups, and I have to see if I'm breaking this into equal groups, how much is going to be in each group. Okay? Now, I first look at my hundredths and I think, can I give each group 100? Well, I only have 3 hundredths, so can't do that. So what I'm going to have to do with my hundredths is to change them into tens. Okay, so let me explain that again. I have 5 groups. I could give this guy 100, and this guy 100, and this guy 100, but these 2 wouldn't get anything. So we can't do that because we want equal groups. So if I bring this to my tens, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to cross this out because now it's not 100 anymore. I regrouped and I made it 10 tenths. And now I'm going to bring this one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cross it out because I don't have that 100 anymore. I made it 10 tenths. Now I'm going to bring this one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. cross it out. Now I don't have hundreds. Okay, so I had 8 tens. I just brought 10, 20, 30. So how many tens do I have now? So 10, 20, 30, and 8. I have 38. Now here's what I like to do. I just like to write how many I have so I don't get confused. So now I have 38 tens. Right, now you could use your knowledge of 5 and 38 to figure out how many would be in each group. I mean, that would be faster than going one for you, one for you, one for you, okay? So if I have 38, and I know, let me put up here my multiples, 5, 10, 15, 20, 25, 30, 35, 40. If I know that 5 times 1, 2, 3, 4, 5, 6, 7, that's what this means. This is 5 times 1, 2, 3, 4, 5, 6, 7. If I know that 5 times 7 is 35, well, that tells me I can put 7 tens into each group, because that would be 7, 14. Oh, what am I doing 14? I'm counting by sevens. I'm sorry. It would be 7. Well, yeah, 7, 14, 21, 28, 35. Oh, my goodness. Yes, I was counting by sevens, which I should have. So here's what I'm going to do. See how I'm confused? 1, 2, 3, 4, 5, 6, 7. That's one group. And that's going to go over here. 1, 2, 3, 4, 5, 6, 7. Okay, now let me count 7 more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's two groups. 1, 2, 3, 4, 5, 6. Oops. Okay, let me do this. 1, 2, 3, 4, 5, 6. Let's do those 7. That's why it's good to make them kind of apart so you don't overlap. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And I always double check, okay? Because you see me make mistakes all the time. That's life. 1, 2, 3, 4, 5, 6, 7. Whoa. 1, 2, 3, 4, 5, 6, 7. Now, this makes sense to me because I have 7 times 5 is 35 plus the 3. I have 3 left over. Okay? Understand what I'm saying there? I had 7 tens, okay, times 5. So that's 35 tenths. But I still have 3 left over. 35 plus 3 is 38. So far I know I'm counting them correctly. And you know, as I keep saying, I make mistakes, so I like to check over several times. Okay, so now I have 3 tenths. Well, I have 5 groups. I can't put them evenly yet. So what am I going to do with those 3 tenths? Just the same thing I did with the hundreds. I'm going to make those 3 tens into ones. So if I had 30, that means 30 ones. So I'm going to bring this one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm going to bring that one over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my last 10 I'm going to bring over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't have any 10s left here. Okay, my hundreds are gone, my tens. This is what I have left to divide. Now, I just brought 30 ones over, 3 groups of 10, and I had 4. So now I have 34 ones. 34 ones. Let's look back at our multiples and see if I don't confuse myself, okay? So, I know that 5 times 6 is 30. So that means there's going to be 6 ones in each of these. So I do 1, 2, 3, 4, 5, 6. Don't forget to 1, 2, 3, 4, 5, 6. All right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I should have made this look more like an arrow so I don't get confused with it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3. I've done 3 groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and now I have 4 left over. So I had 6. Was able to make 6 times 5 is 30. I have 4 left over. My leftover is my remainder. That's my remainder of 4 ones. And remember, you can't have a remainder that is the same as the divisor or greater than, because that means you can make another group of 5 or whatever the divisor is. So now I look at what I have here. I had 7 10s in each group and 6 1s. That means each group, each of my equal groups is 76 with a remainder of 4. I had 1, 2, 3, 4 left over. So up here I can put 76 remainder 4. Notice I put my 10 over the 10s place, my 1s over the 1s place. So that's a picture way, and I know some of you prefer that. And again, this is a great way, but the problem that I'm seeing with some of you is that you're trying to make your pictures too small, and then you're not getting all of your numbers. Okay? So now the other way is called the partial quotient. And the quotient is your answer in a division problem. So when I think of partial quotient, that means I'm going to find parts of the answer, and then I have to add them up to find the total quotients, total answers. So to set this up, I'm going to put my divisor on the outside, my dividend underneath, and I always start with my greatest place value, and I'm thinking if I can do 100 times 5. Can I do hundreds times 5? Well, no, because 5 times 100 is 500, so we can't do that. So now I'm going to look at my 10s. All right, so here's what I suggest you do. You box this. What this means is 38 10s. Okay, that's 38 10s. Now over here, I can still use my multiples, okay? And remember, I can't go above my 38. I got to see as close, I have to get as close as possible to 38 without going over. So as I found out when I was drawing my pictures, I could do 7 times 5 is 35. I could do 7 times 5 is 35. And use that information to, instead of multiplying by 7, multiply by 70, and I like to put mine right here, and I like to write the multiplication so I know it's 70 groups of 5. I like to do that so I don't forget what it means, this number that I'm putting here. So if I knew that 7 times 5 is 35, 70 or 7 10s times 5 is 35 10s. That's what that means. Okay, so far I have 70 groups of 5. Once I do that, I have to subtract and see how much is left over that I still have to break into groups of 5. So 4 minus 0 is 4. 8 minus 5 is 3. I have 34 1s left. So again, I think of my multiples over here. And what's the most that you can multiply 5 by to get as close to 34 without going over? Well, if I multiply by 6, I would get 30. Okay? And then when I subtract, I have 4 left over. 4 is less than 5, so that's as far as I can go. Now, in your book, what they do with their partial quotients is as they solve the problem, they put them up here. 70, that means 70 groups of 5, and this one means 6 groups of 5. And just like we're going to do here, they add them, and this would be 76. 76 groups of 5, oops, with a remainder of 4 ones. Okay, we got the same answer, 2 different ways. Whatever way works best for you, use that way. Just be careful, again, whether you're using this way or that way, that you double check, because I'm a perfect example. I make mistakes, and that's why I have to double check. All right? Hopefully that helps you.